Hi, everyone. My name is Gyorgyi Tuba. I'm a research associate with Laurentian University, and this presentation is going to be an update on phase 2 of our alteration footprint study that we are conducting in the Larder Lake area. So in the beginning, I will give you a short introduction to our scope and aims, and I will recap the phase 1 proceedings just a little bit, so just to provide context for the second half of the presentation, which will be about our 2021 field season and what we accomplished during those weeks out there. And then I will finish with giving you a glimpse into our future plans. So just to give a short introduction again, this project is to address the question of contrasting gold endowment in environments that are geologically very similar. So specifically, we're working in along a 12-kilometer segment of the Larder Lake Cadillac Deformation Zone between Larder Lake and Virginia town. And this part of the Abitibi hosts a series of gold deposits which have the same host rocks, the same structural environments, and yet the gold endowment among these deposits is very variable. So we are looking into this question, what can cause this difference in the gold endowment from an alteration point of view. So we are comparing and contrasting the alteration features in well-endowed areas versus less endowed and barren areas along this stretch of the Larder Lake Cadillac Deformation Zone. So this is our area of interest. We are basically focusing on the ultramafic and mafic volcanic units of the Larder Lake group, as well as the metasedimentary units of the Timiskaming group. So we sort of excluded the felsic volcanic units and the intrusives from the studies just because of time concerns, basically. And in the phase 1, we took a very detailed look at the alteration systematics of Ker-Edison. So we chose Ker-Edison because this is our very well endowed end member of this spectrum. So it has over 11 million ounces of gold produced over historical years, and this study is pretty much ready to be wrapped up. We did a detailed reconstruction of the alteration history in the area, as well as we did geochemical mapping at the site using surface and drill hole samples that were provided by Gold Candle, the current owner of the Ker-Edison site. And we will add an oxygen isotope study to the story in collaboration with the Source to Sink research team at Laval, and finish some mass balance calculations, and phase 1 is pretty much ready to go. So we just started phase 2 this summer. This was our fieldwork. We did alteration mapping and a sampling campaign to acquire geochemical data pretty much everywhere else but the Ker-Edison site. So these are the areas that are either barren or not as well endowed. So this will be the other part of the comparison. And in 2022, we hope to extend this in 3D with some core logging before we can put together our final model. So I will give you a short walkthrough on the most important alteration types that we are looking for in the area. So this is going to be a recap to phase 1 and sort of like a summary of the most important findings at Ker-Edison that are relevant to our fieldwork in 2021. So this is the geology of the Ker-Edison deposit. It's very, very similar to all the smaller deposits that are hosted along this segment of the deformation zone. The ore bodies are hosted by ultramafic and mafic units, and the whole system is in the footwall of the Larder Lake Cadillac Deformation Zone. Now, during the detailed study, we distinguished three major alteration events, which I like to call the pre-orogenic, the orogenic, and the post-orogenic phase. And the pre-orogenic phase is pretty much some signs of seafoil alteration, so serpentinization in the comatiite, and also the regional metamorphism that resulted pretty much in a boring chloride alteration everywhere else. So I'm not going to be going into much detail on those, but I will be talking a little bit about the orogenic phase. So this is the alteration event that produced the gold at Kerr Edison. And this is itself is a multi-stage alteration event where we can follow through this fluid evolution from a host buffered system to a fluid buffered system. And these stages have their sort of staple alterations, and these also overlap in space and time. So in 2019, I did surface mapping at the Kerr Edison, and I drew up these alteration zones that surround the historic ore bodies. And pretty much what I'm gonna show you now is how these alteration zones developed from each other, and how they are situated in space and time relative to each other. And I will completely skip the post-orogenic phase for this presentation. So the earliest alteration that we can pick up in the field is a strong talc chloride alteration that is most prevalent in the ultramafic unit. And this is none other than just an addition of CO2 to the original units. So this resulted in this strong alteration in the ultramafic, but it's also present in the mafic volcanic units. And as the alteration proceeded, and there came even more CO2 to the system, here we produce our lovely brown units. So this is the carbonate alteration that we see everywhere, pretty much along the Larder Lake Cadillac deformation zone. All the host rocks, so the ultramafic, the mafic, and the sediment units are just pervasively replaced by carbonate with some addition of quartz and chloride. And this phase also came with albite alteration in the mafic volcanic units. Now, another stage produced the first gold mineralization, and this was the sulfidation stage, which is most visible in the mafic volcanic unit. And here we have pyrite and xenopyrite dissemination hosting the gold. And also they come with an advanced albite alteration around the sulfides, which is very visible in the field. It looks absolutely gorgeous. And this pyrogenesis is the same for the so-called Albitedykes that are mostly intermediate in protolith. Some were felsic, but these are a couple of meters wide to a couple of centimeters wide. And that alteration is again pyrite or xenopyrite and a lot of albite. Now this leads us to the potassic alteration, which is in turn most prevalent or most visible in the ultramafic units. We have this very gorgeous emerald alteration, which is caused by fuchsite in the ultramafic units. And the potassic alteration stage also has an overlap with the onset of the quartz carbonate veining. Now, in the ultramafic unit, the quartz carbonate veining, which can be actually very, very strong, forming hydrothermal quartz carbonate breccias. So this is the primary host for the gold mineralization in the ultramafic environment. So basically, if we look at this very simplified, very generalized map, we see that towards the mineralization, the ore bodies, we usually have an increased amount of cerussite or fuchsite, and carbonate and quartz, and the talc is most prevalent, most like the strongest on the distal parts to the mineralization. But of course, this is a very, very simplified map. And if we go back to the original map, we see that the zonation is there, but for example, in the eastern, the northeastern part of Kerr, it doesn't work that perfectly with the projected ore bodies, and also on the outcrop scale, the alteration overprint on each other and how they are situated spatially relative to each other can be very chaotic. So to resolve this problem, what we did at Kerr also is we took the about 3,000 grab and drill core IC sample and the ICP data for that for Kerr provided by Gold Candle, and we developed sort of like a geochemical alteration mapping method based on the ICP data. So we set up alteration indices specifically tailored to the Kerr environment, and we are thus able to pinpoint and plot on a geological map the different alteration types. So on this slide, what I'm showing you is on the left-hand side, I selected the potassic and sodic overprints, so those that do carry gold or associated with the gold forming event, and I plot them against the chloride, so the background barren alteration on the right-hand side. So this is how we use the geochemical data to sort of resolve this very generalized map. And this is basically what it does is to pinpoint the alteration centers. So this is something that we are hoping to do in the other part of the area of the interstellar study area. And so this brings us to phase 2 and our 2021 fieldwork that we did. And so on this map, I plotted about 150 samples that we took. We pretty much covered all the mafic and ultramafic outcrops along this stretch of the deformation zone. And we also set up distance profiles in the sediment. So leaving the deformation zone, we have these series of samples, and we will see how large the dispersion halo, for example, for CO2 and other elements and compounds in the sediments are. And you will also notice that there are these cross-hatched areas. So I do have an additional about 50 samples covering those areas too. But I do have a confidentiality agreement with ore finders and Mist and Gold River, the property owners. So I cannot show you the sample locations or really tell anything about those samples. But just rest assured that those grounds are pretty much covered too. So in the first round, what we can do, and this is just based on field observations, we can color code the samples to get a sort of glimpse at the alteration types you are working with. And I'm going to zoom into this area because we have the most information on this map here. So this is the area that covers the old Fernland deposit, the Chamonix deposit, and also we have Bear Lake here at depth. This is not projected on the surface, but it's here. So just based on the field data and the field observations, we can see several things popping up. So the carbonate alteration is quite ubiquitous along the Larder Albitedykes deformation zone in the volcanic units and the proximal sediments, and it gets harder and harder to pick it up as we leave the deformation zone. But just how wide this dispersion halo is, the geochemistry will tell us. And as for the potassic and sodic alteration, we see that there is a strong spatial association with known mineralization sites on the map scale. So if we take a look at this map, we see that there is a lot of fuchsite alteration, so a lot of the potassic alteration going on in this area, which is generally endowed in gold. But if we take a look at how this is distributed the intensity and the extent of these alteration types. We see that, for example, west of Chamonix, the potassic alteration can be followed along this ridge for hundreds and hundreds of meters, whereas in the east, the transition from potassic zones to the talc zones happens in about 10 meters. So we do have these separate little hotspots and upflow zones on this scale too, just as we saw at Kerr-Edison. For the talc alteration, we can say that it does happen. It does pop up in close proximity to the potassic and sodic alteration. So we do see these zones very close to where we have the fuchsite. And this is the first step. So we will bring it forward from here. And of course, as I said, this is a very biased data set at the moment, just because we do not have the geochem just as yet. And just how biased this can be, I just brought you some images to show or to highlight some of the problems that we may encounter during the mapping of these alteration types. So one would be the perceived alteration intensity. So in this outcrop, we see a sandstone bed and a conglomerate bed, and just going by the weathering surface and the color and the alteration that we see, we would probably say that this unit is more carbonate altered than the conglomerate. And this is just because permeability contrast between the sandstone and the conglomerate. So it doesn't mean that you know, the carbonate alteration wasn't there. It's just it's just a permeability contrast. And also what we see very frequently happening in the mafic units is that the fluid was focused along the flow tops. So whenever we have, for example, hyaloclastite breccia or this mafic volcanic breccia, we will see a much more intense albite alteration, whereas in the flow centers or the flow interiors in the massive mafic volcanic units, it's much harder to pick out in the field, but the geochemistry actually, it follows it up very nicely. And so another example would be sericite alteration in the sediments, which can be very cryptic. And unless we have, for example, ultramafic claws that would be preferentially altered to fuchsite, it is quite hard sometimes to tell in the field whether we lost the sericitic alteration in the sediments or not. Talc has a tendency to disappear on us. The intensity of the talc alteration can vary or wane off from intense to weak in a couple of meters. So if we miss an outcrop that is like a desk size, we may not find our talc zone. And sometimes alteration that should not be there pops up in structure zones because of younger structure overprint. For example, this very strongly potassic altered ultramafic block in the middle of the boring chlorite mafic volcanic unit. So yeah, these are the sort of nuances of trying to map alteration in the field. And this is where we are at now. So as I said, as for Kerr-Edison, it's pretty much wrapped up, and we hope to have it published in the following year. And for phase 2, we are waiting for the geochemical data to come back to start processing them and generate the alteration maps. We would like to extend the alteration mapping in 3D, so do a lot of core logging next field season. If we can arrange it with the companies in the area, and then we will compile and compare our data with the published data and work out our alteration model for the area. Thank you.
I just want to congratulate you. This is a very nice study. When Smith did his master thesis at Kerr-Edison, he put a lot of emphasis on the Albitedykes. He was describing pre-mineralization, syn ore, and post-ore Albitedykes. I wonder if you could comment on the Albitedykes. You mentioned Albitedykes a little bit, but I wonder if you could say a bit more about the Albitedykes.
Yeah, I didn't look at the Albitedykes specifically, as in let's try to find out what the Albitedykes are, because I know there's a lot of controversy and around them, and for a while they were incorporated in this magmatic hydrothermal model of Kerr, right? So the idea was that these were the feeder dikes for this this magmatic hydrothermal system that resulted in Kerr Edison. And I'm pretty sure that there are different generations of dikes there. There are at least two that overprint the mineralization. They are not albite altered though. But everywhere else where I picked up these dikes, those were the protolith was different. They were always mafic or intermediate or sometimes basic, but the alteration is very similar. And personally, what I think is that they have nothing to do with mineralization. They are mineralized because they encountered this fluid that that is responsible for both the albite alteration and the potassic alteration. So the difference between if you will have the albite alteration and if you will have the potassic alteration is just down to the host. So the ultramafic, because of the higher magnesium-iron ratio, will be potassic altered, and the mafic rocks from the same fluid will be albite altered, and they will also have the sulfide alteration because they have higher iron, right? So I think it's just down to that.
Yeah, I fully agree with you. The albitite magma, that does not exist anyway.
Yeah.
But thanks for your answer. That's good.